Right. Good afternoon. God bless you, everyone. Supposed to alive. So, welcome to another stream. Last stream, we were getting the debug visualization working for these detail materials. So, essentially, detail materials offer a way of putting volumes on top of a shape that will ray march into. That's the idea. And we're currently just trying to write the code. So this box represents material space, and for instance, the cube is here, will be a material space, right? It'll be around there. And this is symbolizing the ray, the starting position of the ray. And it's symbolizing all the, excuse me. It's representing like basically traversing through a grid inside the material and spawning a bunch of spheres inside it, right? That's the idea. So I think what we might do is, so today we're just going to basically finish off this visualization and use it to help debug our code that we've got. And I hope we get that done today. So then we can move on to actually ray marching into the objects and then getting stuff working for these detail materials, which would be like super cool. And yeah, it's going to be awesome. So start off with a quick prayer. Father Lord, thank you for this day. Thank you for the lovely weather today. Thank you for our homes, the food you provide us, the time that we live in, the access to knowledge that we have, and it's really great times that we live in. We have access to like hot shower and everything like that every morning. Truly blessed to live in this time. We thank you, Lord, for that. Help us have a good stream today, successful stream, get the stuff I want to get done, achieve, but also for the viewers to have a good time whilst they're watching and have a very fruitful experience. Also pray that if anyone who's watching is struggling with it in their life right now, I pray, Lord, that you visit them. I pray, Lord, that ultimately before they pass away, they receive the finished work on the cross, the payment for their sins by you, Lord Jesus. And I pray they humble themselves before you, Lord, and receive just the free gift as faith, salvation, and the Holy Spirit in full. Thank you, Lord. In Jesus' name we pray. Amen. Cool. So, amazing. Always on top of that. So, graphics materials. Now, one thing about doing right, we've got a bunch of spheres inside. So, like, imagine this grid is represented again. The outer rectangle is the material space. When you render a cube, like we've got this cube in the background, we've ray marched into it and hit the surface. Ta-da. We want to add more detail on top of it without having to be like, well, I've got separate brick materials for maybe you want embedded rocks or embedded moss, right? No, we want to have ways of like putting that on top. So we're adding like these things called detail materials that you can ray trace into, basically. That's the plan. So in 2 seconds. Welcome back. Yeah, so these spheres represent a volume that we should be ray tracing into, and then there'll be like some sun distance field or maybe a ray traceable object that we continue on ray tracing / ray marching against. And these will just be spawned on this. They'll be spawned in amongst the grid of that 3D material, but they can be they will only be accepted if their distance touches the surface of the the geometry underneath it, right? So we'll have to do a sun distance field test. Now, So currently I'm spawning like 4 in a grid. And it has problems where they're not evenly spaced out and stuff like this. You know, I feel like we should just do 1 per grid and then we don't have that problem. So 1 sphere per grid and then a random offset and then a variable size. So yeah, I think that's what we'll do. So brick, no, we're not looking for brick. We're looking for a detail. Cool. Lovely. So let's change it briefly. Let's make it such that there's no longer 4 spheres per grid cell, there's just 1. Alright, what's he complaining about now? Oh yeah, so there'd be an SI, wouldn't there? Yeah. What are we seeding? So it'd be cool if we combined the grid cell. Where is it? The grid cell that we hit. No. You gotta find this 2D basically. Figure out the best thing to stick in here. Cool, so we've got 1 sphere per grid cell now. So what I'm thinking about doing is we ideally want to make it configurable, the number of cells and stuff like that. Currently making it like what is grid dim at the moment? So how many cells in there? So it's where's our 1? 4. Yep, good. So what we would like to do, can we up the number of, can I up this to like 1024? Is that going to be possible? Right, supposedly that's okay. I didn't realize you can have that many big arrays on GPU, but seems to be manageable. It's crazy. We'll see how it goes when we actually touch the memory. But yeah, only one. Anyways, so yeah. What else did we? So we've got grid dim. This is perfect. So this should be grid dim. There's the number of cells basically. Yeah. So rerun that. Ooh. So if we change, so while we're going outside here, that's another big problem. Like, what's that doing? Yeah, we should probably stop it there. And it's happening. It's hitting multiple times inside there because that's what the magenta means. Yeah, we've got still got some problems with the iteration pass, but no worries. Hang on. Get rid of that check. We've got the grid exit check. Right, so let's find a place. So we call that's probably... Bit strange. Okay. Yeah, got some weird problems here. So it's multiple times in this box. Not good. It's landing in this box to search as well. For some reason, this box here. Bit weird. But it's then skipping directly into this box, right? That's okay. It's okay. So what is the problem, right? Why is it doing that? So let's print out. Let's see the printout. So one means it's the start of a new frame. So the 2 is the grid. So 0 on the X, right? 2 down, 2 up, sorry. So then it goes to the right by 1. Yeah, then it goes down to the right. Okay. Then it goes to the right by 1. Oh, and then it goes here, and then it wraps around, so it lands up landing here. Right, I see. So that's the reason why that one's lit up. It's because it's gone outside. So it shouldn't be going outside, but it's gone outside because... Right, so our grid is 2. Sorry, it's 4. We divide by 2, gives us 2. We have 1, 3. So if your cell coordinate is greater than or equal to 3, then bail on it, please. Maybe we should just add 2 to the chord. So add, not add 2, add... Hang on, so if it's 5... You want to add grid dim divided by 2 sil. Because right now it's... Hang on, it's not going to be odd though, is it? Yeah, it's never going to be an odd number because we multiply it by 2. Right? So that means we should just be able to basically that grid dim means IVEC 3 this, I think. Well, that's the only problem with our build system is the console output and the build stuff is all in the same thing. Yeah, so if we spam printouts, then it'd be cool if we had like different windows in a sense. You know, one would be the output, the other one would be the build output, you know, just like side by side. Anyway. Or maybe you could keep the build info at the bottom and then the standard out here, I don't know, but stuff to sort out in the build system. ABS. Well, don't need the ABS anymore. Cool, I think that's fixed it. So no longer do we go out of bounds. Yes, this is what's really great about running this visualization is that we can solve all the problems in the code in a simple 2D way rather than 3D, and then like purely just tracing numbers down and seeing where the problems are. Now we can visually see it. So these cells are red, which is great. We're getting hits, but we're not hitting this sphere here, which is weird, right? It's not showing up red. So that's another problem. Yeah, why don't we solve that while we're here? So there's a few things I wanted to actually sort out. Is the whole sphere hits. So maybe that should be U32. So that'll be the divide roundup. We have one of those in shared, don't we? Yeah, cool. So divide roundup by there's is it 32, isn't it? Yep. Hopefully that works. So when it comes to the hits, if we divide by 32, yeah. These should all be initialized ready to 0, but we can't guarantee that. So we should just say if sphere index equal yep, then just set it to 0 for me, please. Yeah. So if you're the first of the 32, set that to 0. Cool. Nice. So when we get a hit, 1 shift left, sphere index mod 32. So that'll just go from 0 to 31 inclusively, and so it shifts 1 into the right slot, and we need to make sure we all that on. Right, so that just makes it a little bit better that way. So we go over all the spheres in this debug drawing thing that we're doing, and we're just going to emit some circles now. That it's going to be a hit providing that sphere index divided by 32 and sphere index 1 shift left sphere index, which is mod 32 is a 1. Should do it. Right, so we sort out that. So the other thing we want to do is like, you know, if Boolean right, if sphere index is less than nn, as it's called, that's what I've called it, just the number of spheres we can support, so we don't overflow and then crash the GPU. So I guess if we hit that, what we can do instead is just render a box and say, hey, you've overflowed it. Well, yeah, why don't we say like, if this is less than nn, then do the rendering of the spheres, and then we can just render a red box or something like that, signifying some kind of overflow. Because ideally we want to see all the spheres, don't we? This is the whole point of the debugging. So vec to 0, the size vec to 0.5 maybe, and then we'll just do a big fat red. So the board will be infinity. RGBA 8 red. Right, so not got anything rendering, but oh really, you want to work now, do you? So my build system needs a bit of a... Oh, okay. The code was compiling fine. My build system's fine. Right. So, cool, now let's investigate that problem we was going to be looking at. So this is where the ray starts, it's going down here, but for some reason it doesn't hit this guy. Not very nice. Why? Maybe it's something to do with this. Hey there, Olex, the dev. Yeah, I got hot reload. Just sometimes with the build system. So my shader hot code reload works pretty well. Like it refreshes really quick. My CPU side has bugs. So, and I don't really program so much on the CPU, so it doesn't really matter that much. But when we do more CPU side programming, I want to fix it up. But yeah, so part of my issue is currently I've got my build system and it's watching in the background. So my build system invokes as a child process the game, right? So when the game is spamming out stuff into the terminal, like all this shader debug, what happens is I will rebuild something and the build system's like, oh yeah, we've rebuilt something, and it sort of tells us in the terminal, but the game comes along and goes whoosh, with all this sort of console output. So I probably need to separate those out somehow into like separate windows, if you will, maybe by doing the, the console, what is it, the T100 stuff where you can like have full control of the terminal, like paint in certain places, words, or maybe yeah, I don't know. I just got to figure it out. But yeah, for now we just live with the consequence of if I don't understand what my build system is doing, close the game and run it again. But yeah, these paper cuts, So it could be something to do with this. If the material edge distance what's this doing? Are you saying you're near the edge? Then skip it. Yeah, this is saying if it's near the edge. I think we've got to get rid of this. Yes, that I used to be like, if it's going to go outside the material boundary, then like problem. But what was I going to say? Yeah, if the sphere is going outside the material bounds, then it's a problem. But the way I'm thinking about solving it is yeah, it's not really the best way to solve it. There's other ways to do it, I think. Maybe it's in the user's control. I don't know yet. But making a clip against the edge of a box doesn't solve all cases. It just solves the cases where you got like a cube as a model. So it's not really a good solution. Right, so why Why isn't there a hit? So did we land here at some point? So we can do this PP thing. I've just got a macro up above where it says like if I can print. So there's a certain pixel that's printing on only, right? So let's put out right, so it seems like we never get any hits. Let's move that out of the if statement. -1. So the 1 starts a new frame. We've just got a bunch of -1s, yeah, for the 5s. So it's not very nice. Very strange though, because according to my debug drawing, this is big. So does that mean my debug drawing is wrong? Like if I were to like slowly increase this radius, well, let's increase it to 2, right? Does it hit? Oh, now these ones hit, but this one still does not. Bizarre. You know what it could be? Could it be the sphere center being wrong and therefore this... No, because the sphere's position is here, so we know it's in the right place. So we times it by 4. Ah, we did 2. I'm so confused. So we did 2, that one works, but then if you go up any more, this one then starts to work. And then that one just gets too big. But it's weird. Let's visually see it. Interesting. It's weird. Good morning, Austria. Welcome, sir. How you doing? God bless you. Hope you're having a good day so far. What stuff you been up to? Oh, I don't know what's going on here. This is super bizarre. So, luckily we've got printout information. So we can tell what this cell center position is. Yeah, we know that it's offset there, so it should... The ray origin... So we could have some fun and just debug draw all of the hits as arrows. We like having fun, right? So do I. So what we can do... So from ray origin, yes, can you go... do a vector towards there. Dot xy, dot xy, dot xy. Right, so interestingly enough, hang on. Right, so 1 in terms of depth and 0, 0. in terms of a thickness. So if we did like a red maybe, let's make it twice as thick so we can see them if they overlap. Right, so there's only one being drawn for some reason. Bizarre. Oh, right, yeah, because this happens on the first of the 32. Whoops, wrong place. Don't mind me. This one. Right, so apparently none of them getting hits. I'll put it here for a minute. Yeah, so here's all the ray. Yeah, so it's clearly from the ray position to here, yeah? So, clear as day. And you got the ray direction. The ray direction is correct, isn't it? Huh. So I'm just doing intake start, right, normalize it. Just normalize the 3D one though. Fresh haircut. Hey, Captain Chica. God bless you. Yeah, I got one. When did I get it? I get it last week. Hey. Struggling to figure out time sometimes. When was it? Yeah, it was last Friday or Saturday. Yeah, last Friday. So yeah, still kind of looking pretty new, isn't it? Infinite Henrys. But yeah. Right. Also cut my son's hair not long ago. Yeah. It's really fun cut my son's hair. I love it. I got him a, he's got curly hair. Because my wife is from Zimbabwe, so so his sides were getting a bit long, but the hair on top was as well. So I just sort of like trim the sides down. And he's got like a nice curly hawk. It's amazing. That's great. My barber won't be happy with me once I finish CS 14.3. What is CS 14.3? What is this thing? Let me Google it quickly and do it on my phone because I know what you. Are you talking about? Oh, logic and automata. Oh, about compilers. Interesting. Why wouldn't your barber be happy? What is it about? Because you'd be like boring the crap out of him with it. That's awesome. Yeah, compilers are fun. Oh. Leo Slabs is raiding with a pie of 22. What? Oh, Akraz. Welcome, guys. God bless you all. How you doing? Happy Friday to you all. Saying that no one cares about the. Oh, I see. Right. Okay. But yeah. Welcome Raiders. So what we're doing is working on 3D materials. It's pretty cool. That right there in the background is technically, well, you guys in our secret is a cube. But we ray march into it. and we reject the pixels if we miss, and we go to the layer behind. We've got 4 layers. We've got a 4-layer frame buffer, and that's called a geometry material. It's just a made-up thing. We like making up things here. New language, new things. So we also are working on a new thing known as a detail material. This is what we're trying to get right. So inside this 3D volume of material, we're trying to spawn little volumes of detail, which is known as a detail material shader. And you'll be able to ray march into that little bounding sphere and find more detail. So like a ball of moss. And get this, each bounding sphere will have a different moss. Billions of mosses randomly generated. And all done at runtime, procedurally in code. And it won't just be moss, there'll be other things. Like maybe stone. You know, maybe grasses, if you can pluralize grass that way. And yeah, that's what we're working on today, is doing the debug visualization. And yeah, trying to make it work very nicely. So we're just trying to, inside a grid, randomly generate a bunch of spheres to then spawn down. And these will be tweakable parameters as you sort of paint down what detail material you want. So yeah, that's what we're doing. Any questions, feel free to ask away. Thank you so much for the raids, sir. So the green is our array, and the red arrows are just, you know, ray to sphere. So should be working, I think. What have you done? Maybe this has been copied incorrectly. So I did change it. Which one did it do in the end? I think it was this one. Yeah, so we swapped out OC. Yeah, so we did that manually, right? Origin, center position. So it never does an RO in here, right? So hey there. Not sure what Leos is. Yeah, it's SDF stuff. Yeah, so rebranding. So, but yeah, it's a restructure, rebranding. So based on Game Van Engine, but code base, but changed it a bit. We're no longer doing ellipsoid rendering. We're doing SDF. We're doing meshes, but 3D materials using signed distance fields. So ray marching into surfaces and stuff, all procedurally done with code. So, you know, so there should be no UVs. Hey Kappa. Oh, I see what's guy raided me, was it? Yeah, SDF. Thank you so much for the raid, sir. So you did a paper on... I see. Right, so you're talking about yourself in the third person. That's what confused me. Right. So you did SDF stuff. So what paper did you read? Yeah, Sanderson Field rendering. There are 3D materials, but probably doing a modeler as well using SDF, but it'll compute meshes to render because it'll be fun and powerful. That's the plan. Just sort out the materials first, though, because materials is what makes stuff look good. So I think this is right. Let's try the other one out. I'm just super confused. Like, why? Oh. Yeah, so it's not this function. So what's the problem then? Oh, you're not the guy, right? That's why. I see. Right, that makes a lot of sense now. That makes a lot of sense now. I'm basically blind. I was trying to read the text and it mentioned that guy's name, Laos. Yeah, because when you see, you see. Right. Why you no work? Surely it's not the other way around, is it? I have a feeling maybe the ray direction is a bit off. I don't know though. You know, we're doing a sphere, aren't we? Yeah, okay. I think I know what the problem is. Right. In this debug visualization, there's circles. But I'll give you, but technically they're spheres. So they're not that radius all the way around. So that's the reason why some of them are missing. So we want to align them to the ray. This offset dot z equals 0. I thought that would have been it. Oh, sorry. Sphere center position. Sorry, what's the z value again? 1. Boom. There we go. Okay, so this needs to be removed. Right. But just while we're debug visualizing, this needs to be here. Very good. Okay, so now we can get rid of the other debug drawer and we can carry on. So, oh wait. Why is that one being hit? Oh yeah, sorry, it doesn't actually stop here. Ignore that. It keeps going. Yeah, that's not really a nice visualization then, is it? We should make it end a little bit further then. So we'll say, let's say one along the X. That way it should come past everything. Cool, very nice. So what are we doing now? Right, let's quickly move it, animate it, and watch it work. So that's a bit problematic. You see the spheres, they kind of change how they look based on what route you take. That's not very good, is it? So you need to be careful of, like, we don't want to array from a different angle coming across a completely different universe, right? When it lands in a particular cell. So that's a next problem to solve, and that's just because of our random number generator. Yeah, ain't got gas. That's why. In it. British. So the seed. Yeah, so depending on which cell you land in. Right, so what it should be is the seed combined with the okay, with the cell coordinate. So the seed will be defined by the we've got to figure out where it comes from. The outside, basically. I don't know where it comes from. It's unique, as the comment says, make this unique per something. I don't know what that something is, but it's something outside. Yeah, I don't know where it goes. Maybe it goes in the material and the user can sort of randomly generate it, or maybe it's per mesh node or something like that, or we'll find out. So long as let's just find this hash function that we're using. So I've got this one where it's got this in-out RNG state. I think maybe you want to have a way where you basically do we just mix? Do we have like a way to mix? Yeah, so where is the mixing code? Flatten hash. Honestly, it could probably be better, that one. Yeah, we probably want a hash mixing function, I think. So mix the seed with the a hash of the coordinate. But yeah, the nice about the flattening is it's quick. Yeah, so we take the 3D hash. Gotta be careful. So we could flatten right, so see what sort of ideas it's got. Yes, it's this sort of stuff, right? Shifting and multiplying by a prime, large prime. Right, so this is a way to combine, multiply, XOR, nice. Oh wait, that's not really mixing, is it? We're talking about combining though. Purpose of hashing. So the idea we're hashing, I'm not sure what's popped up there, but anyway. Oh well. So the purpose of hashing is you're basically making something, an operation which will be slow, quick. So a prime example is string hashing. So there's multiple reasons for hashing. Oftentimes, so you can use hashing to basically as a pseudo, so fake, right? Pseudo fake random number generator. So you can just get a random number, then do whatever you want with it. And that's how random number generators work, is just with this sort of stuff. You can also use hashing to combine two integers together and stuff like that. To combine more data into a single value, rather than just moving that value, that hash value around. So the idea is, if for hashing, you can use it to also compare things to say basically they're equal, based on some probability. So say if you have like 64 bits, like so long as you like the chances of collisions is extremely low. So if you hash a string into a 64-bit value, you can get like it would always hash into the same value, right? Providing the same string. So if you hash a different string, it's most probably got a different value. So it's a cheap way of doing string equals. With tons of things basically, but the the problem is you might want to have a guaranteed check, because you can get hash collisions. So you basically you can use the hash equality. It's a simple one number check to simply check strings quickly, but then only when the hash is equal do you check the full string. So you can use those optimizations like that. Hash tables use hashes as well to pick buckets and do, again, key comparisons very quickly. Yeah, so that's basically it. Pseudo random number generator is the other way, which is what we're doing it for right now. You do it in shaders a lot because you want like a quick, cheap random number. So you just do it this way. So I'm trying to find a way to sort of combine just sort of some good little hash function with the Momo hash style. Treats two inputs and progressively eats them into a hash state. That's a bit much. There's a simple one though. So combine the two ints this way, then pass it through the triple day2 mixer, right? It's probably about the same, to be honest. Yeah, we don't really care about collisions too much. Easily apply different weights to each component. No. So I think we can use this one. It's cheaper. Yeah, we'll do like this thing here, basically. Cool. So, right, let's just get a hash mix. So flatten. And then a mix. So you got an A and a B. So you probably just say flatten. So it's called X. Can I have 4 large primes, please? There we go. We can double check them. Use large odd primes. Cool. It's a prime. Let's go. 1 prime. So next one. it lied. I asked for a prime and it gave me a composite number. What's that? What's the difference? ChatGPT lied. No, sorry, it's Gemini, isn't it? These machines. There's a few different factors there. Well, that's crazy. Ah, it lied again. Yeah, we're good Excel. That's the other way of doing it. The last two are not prime. Two more, please. Try to fool me. You're absolutely right. Please. Yeah. Gotta double check it. It's not vibe coding. Vibe coding means... Vibe coding means you don't care. Vibe coding means you're just going to be like 10 minutes to program the whole thing, right? Without getting in the... As the robot said, when you see, you see. So the thing is, right? Basically, I just use this as a glorified Google search. Because Google searching is terrible these days. You know, Google made it terrible, right? It used to be way good when I was younger. It used to be great. Now I'm in my 30s. They've lost it. You know? Yeah, Script Kitties 2.0, exactly. Yeah, Vibe coding is downfall of software. But honestly, downfall of man has always been... Well, it's been on its way lately. Because man has rejected God. You know, Hosea 4 verse 6. My people perish for the lack of wisdom. for the lack of knowledge. Because you've rejected knowledge, I reject you for being my people. That one. It's happening. You know, we've got so much pride these days. It's like, we have phone. We fly a rocket to moon. We so good. You know. But really, people are in ways very, very dumb. And what the Lord God wants is humble people. You know, I met some guy the other day on the street and he was saying how smart he is. And he was telling me I was stupid. Telling me I'm a fool. Telling me all these things, you know, slandering me on the streets. Because I was telling people they should believe in God. But, you know, spreading God's word. But meanwhile, all I can say is a tree is judged by its fruit. He was saying he's a very, very wise man. But he didn't look like he was living in very wise conditions. So, you know, as Paul says, Romans 1 verse 22, professing to be wise, they became fools. So, try not to proclaim you're wise. Be a humble man. Be a humble man. Let's see if it's lime. Hey, that did it. Alright, what's that one? When I was 10, peak software engineering were Minecraft mods. Now, peak is writing code by hand. How times have changed. Yeah, I would say, yeah, it made sense. Your age would be quite young. You're not too far away from me, to be fair. Nice. Just think about, you know, there's a really great meme. There's such a great meme. We've got to find the meme. Right, so it's, I don't know, it's, hopefully Google can help me find it, but it's like, game engines made in the old days versus now meme. It is such a great meme. Ah. Oh, here we go. First one. It's so gross though, but it's funny. Game developers then. I coded Roller Coaster Tycoon entirely in assembly, so it can now run on most machines. Ooh, oh, you know. Right. We made a shooter game that only takes up, you know, and it takes up 92,280 bytes of space. Oh yeah. Try out a new game. The first few levels are free shareware. Yeah, like Quake and Doom and that. You know, minimum requirements, so long as your computer can turn on. Good times. No, it's game developers these days. Sorry, we can't work on fixing the game. One of our developers keeps stealing. It's yeah, our game is 500 gigabytes. You don't need to play any other games right now, right? Can you imagine that? Also, there's another 50 gigabyte update patch. Optimization. Just get a better PC, bro. Or you need at least next gen to play without a game without crashing. Man, that's so true. These are funny because they're true, right? Our single player game is always in life. Excuse the profanity. But anyways, top quality meme besides that. But yeah. Unfortunately, this is the world we live in these days. You know, and you know how we're going to fix it? Man will merge with machine. You know, we need, you know, Sam Altman, yes, aka Scam Altman. He's on a list. He wants to merge. He wants to digitize his brain, upload his brain into a computer. I'm not sure if he believes that he'll live forever because he's that sort of level of materialist, but I think some people do. It's really strange. People want to upload themselves into a computer and live forever, but obviously it's not going to be them, right? Because people seem to think their consciousness is a byproduct of atoms ordered in a certain order. But it's like, you know, it's just bizarre. Anyway, so yeah, man is going to merge with a machine. That's what they're pushing, right? You've got, you know, transhumanism agenda, right? Not talking about transgender, it's old. Transhumanism. You've got DNA manipulation in the works, right? They're trying to DNA manipulate babies, take out all the infirmities. So that's basically eugenics 2.0. You've got, you know, they're making robots now. You saw the Kung Fu robots the other month. They're going to want to make people merge with robots and upload their minds into a computer. Elon Musk has got his digital ID, sorry, his digital Neuralink thing. Combine that with digital ID. You've got complete lockdown of free will and people all listening to this unholy spirit in their mind. This is the devil, man. The devil's building an unglorified body, and people want to eat it up. I told you the story of how TLS was invented. No, tell me. So yeah, be wary. The devil's coming out to play. Tribulation is coming. Revelation 13 says there'll be some robots walking around killing people for not worshipping it. So, and it says the one more government's coming. So just be careful, by the way. The only way out is Jesus Christ, the way, the truth, the life. The only way to the Father is through him. The glorified body is given to those who believe in Christ Jesus and are washed clean in his blood. Because only his blood can forgive you of your sins. Oh yeah. So cannot wait until that day, which will come soon. Hopefully I've got time to make a game. Anyway, we saw that now. Hashing. I wanted to hash. So there's a seed. We want to take the yeah, so we flatten hash this cell cord thing and then mix. So mix hash, flatten hash, we're flattening the cell coordinate. Ooh. Right, so that means the seed will be reused for all the spheres, and the sphere will be placed no matter which way you ray trace into the grid cell. Lovely. Lovely. Nothing but the name of Jesus. Oh. Was that U vector or something? I think so. Right, we're gonna need it the other way there. Oh, I spelled it as flatten rather than flatten. Flatten. There we go. Right. So now the bug is fixed. I'm pretty sure. Pretty confident in the fact. So the idea is, boom. That. So this one, no matter which way we get into this cell, via this way, then that way, or this way, that way, then that way, this one is always staying there because the hash has not told it to be elsewhere. Ta-da. Nice. Hello, Trinidad Hype. Welcome, sir. God bless you. How you doing? Yeah. So in the 1990s, there was some things happening in the territory of ex-Yugoslavia, and Croats need to exchange messages between city of Ozek, maybe, and then surrounded city of Vukovar. So they implemented software called Kieza Crisis, which was first known TLS implementation without needing manual intervention on sending and receiving parties. Right. Okay. But why do they call it crisis? What was the crisis going on? I'm quite unaware of that. Was there like evil people they were trying to hide their messages from? Cool. So this is working better now. So now what we want to do is make it such that we can change the number of grid. Oh. So yeah, for those who have joined recently, we're trying to spawn spheres on the surface of an object. So we've got this debug shape. And the idea is this is material space. So it's a 3D volume, but we're just doing a 2D slice of it. So the green line is the ray. And the idea is that the ray will traverse through these grid spaces and then ray trace against the spheres inside that grid. So there's only one sphere per grid at the moment. Probably is what we'll stick to. And the idea is the sphere will then be checked against the surface to see if it's okay to use, if it's colliding with the surface. And then it will be accepted as a thing to be ray traced into. And then we can ray trace into it, and inside there'll be like moss or something like that. So, or grass or stone. And so the idea is we can have detail materials that we paint down and decorate existing surfaces, so we don't have to have very bespoke materials every time. We can have components of materials, if you get what I mean, and overlay them on top of each other. So a detail material is just a way of doing it by having these volumes of spheres that pop down. It's just a different way of doing it. Just a thing I made up. Yep. You found it here first, folks. Anyway. So it's looking good. Let's just basically up the number of let's like just change the number of like spheres and stuff. What do I want to do exactly? I want to change the number of yeah, mess around with these parameters up here. These are the configurable parameters, and see how it changes. Well, let's first test the traversal code. Let's keep it directly. So this is cool. I like the way it's doing it. But what happens if we were to go, say, completely diagonal? So going completely diagonal works, right? We're able to go through this box, then that box. Cool. So what happens now if we go completely horizontal? So yeah, it goes through the three boxes, but what happens if we did it on the bounds of the right, so it's stayed in the top one. I think that's okay. Maybe. But yeah, so if we keep it as a directly straight line. Oh, that was interesting. Right, so when it lined back up. Right, we've got some bugs. No worries. Can look at that. Right, so the Khazar, the K, R, I are the three letters from the word cryptography in Croatia. Oh wow, okay. Interesting. So the first letter from the word security in Croatian. And back then, the Croats were fighting against the big Serbian ideology. Hence, they chose the name Kryza, so crisis. Simple play on words, sending the message, the outside world was happening here. Huh. Right. Nice. So they got the word cryptography and security, combined it together, and it's called crisis. Right. Interesting. That is super ironic. And it makes you think. Yeah. Because over security is basically a crisis, isn't it? You know what I mean? You can like have a completely locked down place where your freedom is stripped. Yeah, modern day Britain, exactly. Yep. Yep. You get arrested for Facebook posts. Well, to be fair, apparently on Twitter they posted like, "Oh yeah, we'll no longer arrest people for making posts online." It's like, really? Okay. You know. Yeah. You have to know your rights though. Yeah, you really got to know your rights because police are, they are there to protect people, but they do kind of have the ability to lie. They're just people at the end of the day. Where's the Y? Yeah. So I think we want to make it go to 1. Yeah, so we keep it as -1 to 1. And we want to make it go, probably scale it right down to a very small number. And then offset that to like, so, oh no, just leave it smack bang on 0. Yeah. We want it to move around here, basically. Okay. Oh, it was kind of alright, wasn't it? What's going on? Right, what happens if I were to leave leave one of them at 0 and then just move the line? Ooh. That's interesting, isn't it? So I'm just moving the end point, and it's being super weird. Huh. So if we were to make this 0 point, oh, minus, sorry. Yeah, that's not very nice, is it? So it's not even colliding with any of those boxes. Dun-dun-dun. Right, but it does there. So I think what a bug in the code where it won't collide into the future boxes if it misses one of the these neighboring boxes. That's a bug. So not very nice, is it? Yeah, the thing is, when you're rendering a screen, you're getting all of the pixels like going through these nooks and crannies, so you will see these problems. So it's good to sort of try and solve them now. So yeah, we're basically stepping through each of these, right? So I think the idea is like, there is a printout going on. Right, so the printout that we're getting is, so the 4 would be where the reset is. Let's make it 0 for now. Right, so the 0 is where the reset is, the G1, right, with the 0 here, that's where the frame restarts. Okay, so we just clearly hit one grid and then we don't do anything else. So why does it leave? Well, it would probably be leaving here, my guess would be. So we can print a 5 out with a 0 in it, or let's do a 1, 2, 3 in it. Yeah, so that's a correct guess. So we're missing the object. So what should we do here? So what are you trying to do? So we're missing our own object because we're at the edge, basically. That's what it's saying. All right, so we're missing our own object because we're basically hanging off the edge. So we should probably advance. Yeah, so this just do a max. Yeah, that's the issue, isn't it? Just do max 0. So just assume we want the nudge. All right, there you go. So that helps solve that problem. But that's only because the ray spawned in between the 2 points. In between the 2 grid cells, right? So that's another thing with it. But maybe there's other ways to get into that problem. Like, say, if you used to put a ray, like, going here, hitting there, kind of going at a diagonal, I think, but then hitting this one, then this one. I think that would have caused a similar problem. So we should probably test diagonals again. But let's just keep playing around with this for a minute. Yes, that's looking alright. It's not really causing any problems anymore. That's really cool. So we could try more of a diagonal one again. So with the diagonal, it's like we probably want to do 1, -1, 1, then on the X, but then your Y's are going to be 1 would be 0.5, And it would be minus 0.5. Maybe a take or a plus would have been it, I don't know, but anyways. Then, so that'll be directly diagonal. Yeah. This is cool. So the issue is, first off, is we're not really starting. Yeah, so we should probably say, what's, is it 0.7, isn't it? 777. Hang on. Meant the minus, didn't I? What was it, 8? How do I get to the border? Yeah, so we did 0.8. Right, so we've got this clear diagonal. What we're gradually moving it a little bit up and down, but it's staying diagonal, and we should see that it's able to still traverse. So it's technically starting up there. Okay, that starts here. It's able to traverse all the way through, which is cool. So let's increase how much it moves. So yeah, that's cool. Yeah, so I don't think we've got bugs there. That's great. So if the other one to try it is the other way around, as in coming in from the right to the left. Are we slightly outside the object or something? Yeah, so I guess part of the problem is if your UV happens to land slightly outside the object, it's a bit weird. It's probably a problem to look into, to be honest. Yes, if your ray starts outside the material bounds, like maybe you've gone outside accidentally or something. Is this possible? Wait, hang on. The material bounds should be -1 to 1. So, like, why was... Right, we've got some investigating to do. So we want to print out, what is the cell dim? Cell dim tells us it's 0.4. So yeah, that gets you 0.8 only, right? So there's not enough grid cells. Bum, bum, bum. We need actually another grid cell outside, unfortunately. Right, the maths is completely wrong. All right. So if the cell dim is like 0.4, probably need to round up at that point a seal, the ceiling. So it's a seal. I had that before, you know. I changed this yesterday, but I think I just did a more stupid version. It was seal. And then you times it by 2. Right. So there's something to do with like the debug drawer, I think. So grid. There we go. So some slight problems still. That 4 needs to be grid dim. uh. There's a 4 here as well. Oh, that's a big problem. Right, but if it's a 6x6, you should still fit inside the grid, right? Yeah. No, it won't, because 6x6 is a 36. Bwom, bwom, bwom. So yeah, we need a grid hit sort of like bit set thing. So again, how many grid cells would there be? Well, you're gonna have, oh, it's probably the same as number of spheres, isn't it? So something like that. On init to 32, unfortunately. Yeah, so maybe we should have a zero for loop. Because it cannot be ensured. So grid hit, just a bit set, right? Grid hit 2, this tells us if we have landed in the cell multiple times and therefore color it magenta. And again, just debugging stuff, right? And then sphere hits is the other one. Right, so with this sort of grid hit thing, so we're just treating it as 2D for now, but it is 3D technically. So you do a sort of a grid hit, CI, divide 32, CI, mod 32. Yep. So, hang on. Yeah, so it's already been hit once. Nice. Come on. There's still more places that it's used, obviously, but it's a good start. So the other places when it's used, when it's obviously doing debug rendering, at the end of the shader, CI divide 32, CI mod 32. Beautiful. Now it's got to quickly change the other one over here. Things in the way. Oh, they're here. Alright, I don't know if we've broken the visualization still, but let's double check because it's printing out so much stuff. I don't know if it's still... Yeah, it did compile properly. Good, okay. Cool. Keep going. So it might be nice to draw another box to symbolize the the volume or something like that. So I think we want to draw maybe a black box. So 0.01 maybe. With a 1/2 width. Right, a little bit thicker, please. So this is material space, this black box. And the grid now goes outside of material space. So we want to probably test out once we put the ray outside there. How does that react, right? These are other things to look at. But yeah, we're really narrowing down on these bugs. It's awesome. Yeah, I'm not sure what we've broken now. There's someone else has busted because we've done this, but let's find out. Yeah, so grid dim should be 6. Have a look at that quick. That's a 6, yeah? Cool. So yeah, it's a 3 by 3 with the origin being in this here, yeah? So so it goes, yeah, -3 to +3 basically is another way to look at it. So right, we did an add 2. Add 2 is fishy because add 2 is in the realm of hard-coded nature. It's hard-coded stuff, isn't it? Cool, I think we're back. Yeah, we're good. Cool. So yeah, this is good. This is really good because it is coming from the right-hand side and it's, yeah, it's going all the way through those things. That's really nice. It's cool. Can we do right going up as well? You know, bottom right going upwards. We are. Nice. So it's going through there, there, and there. Yeah. So that's cool. You know, obviously it's going past the end of the ray here because that's just where I've decided to quote unquote stop it, but it is a ray, so it should carry on. So the beautiful thing about this code, though, when it's hooked up to a proper thing, like the surface is inside this object, so inside this material space. So if the t along the ray, so the position along the ray basically, if we step past the surface, which we've already got a distance for, then we can let early out. So we don't have to go keep traversing, which is really cool. The other thing is, the other case though is when it doesn't have a distance, so it keeps traversing. How do we know to stop? Well, the way I've decided is if you go outside the grid, but then like you got this problem here, right? Where, well, this is not the one, but this case here, you've spawned a sphere on the edge of the material. Bum, bum, bum. So what we need to do is basically decide, I think, if you're doing this, right? So we know at the grid cell whether you're on the boundary of the box. So we had that code before, which was something along the lines of like, get the distance to the edge of the box from the current sphere position. I think we can do that. And then take that distance. Yeah, we'll do it here, I think. So you could do an SDF, right? We did it before. But it requires a length operation per per time we test a sphere, which kind of sucks. So we could say, hey, are you at the cell position which is at the border, which is overlapping with the border? And you're like, yeah. And if so, then do this box. I think that's what we'll do. So it saves. Yeah, but then they're most likely the most common ones you interface with. So you could do it here every time you do it before reverse sphere and basically check, well, if it's going to be colliding with the border, we probably want it to be a different radius or something. Just shrink it. One way of doing it. The other way is yeah, no, I thought this. Yeah, there's a few problems here, right? Yeah, not doing the box is bad. Spring is really the best time. Not too cold, not too hot. Yeah, it's also like satisfying because like you've just come out of like 4 months of like pure darkness, and now it's like, it's refreshing, isn't it? Awesome. Yeah, because this room gets quite hot. Well, it's not as bad as my other room that I was in before. This one's great because the sun isn't on it at the end of the day. The sun's on that side of the house, not this side, which is super cool. But yeah, my last place I was living, it was on the sun in the afternoon, so you got scorching. Yeah. So we have a bit of a problem. So I guess I can. Oh, this is super overexposed. Yeah, go Windows. Go. All right, I guess let's look for this one for a minute. HDR to the win for the win. So basically, inside this box, you could have the surface defined as this because it's the SDF, right? Maybe it's like a brick, something like that. Whatever it is, the surface is like this. Whoa. So if the surface is like that, and you've spawned a sphere here. Actually, no, you want the surface to be there. Sorry, don't mind me. Hang on. My brain is thinking. We're talking about the box. Oh, for crying out loud. There we go. So you might put a mesh down, which is like a box, but then inside it's like some kind of like brick-like thing. Whoa. You get the idea. Now, yeah, so this is the other surface. Now, we have, by the nature of the grid, defined this sphere to be here inside this box, but it obviously goes outside of the UV space that we've mapped into. The material space technically starts from here -1 to 1, but the way we've decided to assign the UVs to this mesh means it's such that it's here. Now, such that it's in probably like a 0.77 something like that. Yeah, like a 0.77 rather than like -1. So minus 0.77. But and because of that, how do you know that this sphere that you've got down in this that is kind of the outside the space, but then also inside? What can we do? Like, um, to because the issue is inside here is meant to be like some moss or something, right? So if we were to, this is not going to be accepted because it's actually a little bit away from the SDF here, but um, if it even if it was right, let's just say it gets accepted because of that or whatever, but um, maybe we should redraw that so I can actually. Oh, for all right, let's redraw it. So the SDF that we ready to march into do something like this. Hang on, I'll do Control Y because I can't do Shift Z for some reason. Right, so this is the SDF. So it gets accepted because the distance from here to the surface is greater than, sorry, to the surface, I meant, is less than the distance, less than the radius of the bounding sphere. So it's like, we will accept this. Or maybe there'll be some configurable threshold where you want it to be kind of even more snug to the surface. But anyway, this one gets accepted to be able to be ray traced again. So we've still got to write that code. But it's easy to tack on once we've got all the traversal stuff working well. So how do we solve this problem? Since the UVs are placed on the mesh, and they could be any shape, right? You could have like some weird, funky looking mesh, and just an odd shape. And the UVs could be all over the place, and the material space could be something like that, right? You know what I mean? It could be. So the grid that gets laid down inside the material space. One of the ways is by rejecting all of the grid surfaces which don't, all of the grid cells. Well, no, we can't tell. We can't really tell if that's the case either. Because it can't be based on, it can't be a view dependent check, if you get what I mean. So we can't say like, from this view dependent ray, like how does this get placed? Because you could have a ray which comes from this angle and it's able to hit this volume but not here. So that's, yeah, I think this is one of the problems that we faced in some of the other designs. So, right, so I think the solution that I came up with was like, you've got to ensure that, so the artist who's using the tool has to ensure that the grid that they're using to place down the grid that they're using to place down the... Yes, if we have a geometry material which moves, which basically ray traces inside, if you're going to be using any detail materials, the grid cell size has to be the minimum size of the grid cell size has to be yeah, but that would then mean, because you could have corners, right? I think let's redraw it because I've got some other ideas now. So like, you could have a mesh where it's fitted into a space like this. Oh, for crying out loud, why'd you keep doing that? Stupid thing. Man, can you stop being too intelligent? Right, so it's this weird sort of mesh, right? It's not, the UVs are painted down here, so this is -1, and up here is +1 in material space. So material space is like a texture space, basically, but it's 3D. So if you have, I was thinking you could shrink, you could, basically the person who's doing the painting or whatever, they could say, well, the inset distance of the material must be, sorry, of the mesh. So like, you've got this box or whatever, and the UVs are start here or something like that, but because you ray trace into it, they actually end up being somewhere like here. The surface ends up actually being here, which is a different color. So because the surface is now here, this is maybe not a good example because this grid is so big, maybe the grid will end up being small, but we at least see the thing. So I was thinking you could shrink the grid such that you say the minimum distance that we end up ray tracing into, if you will, like, and hitting the actual surface. This has to be at least in by the grid size or something like this. But then you have the problem where if the thing isn't aligned properly, like we have now, where the grid isn't going to perfectly fit into the object, right? It could be unaligned or it could be just a weirdly shaped object. The grid isn't going to perfectly fit, so the sphere is always going to have a way of coming out no matter what. That's another problem. So we don't have a way as well to query so this is easy to reject because we just say, hey, is this touching this surface, right? Is the sphere touching the surface? And the answer is no. But if it was, right, then you'd get like a cut out volume because it'd be like half rendered. And that's not going to look very good. So that sort of moss that you've got in there, that is attached to here, say. Not going to work. Is there a way to get distance to this object, though, your mesh? I don't think there is. You know, it could be it's comprised of like many vertices, right? It's also in a 3D space. And it's not necessarily going to be uniform for every mesh because it'll be skinned. Well, this will be in local space anyways, it's unskinned space, so that's what you do. So the radius of the sphere, that's the solution. I think I thought about this before, but I forgot it. So at least we found it again, I think. So the radius of the sphere, so long as the radius of the sphere is the maximum radius of the sphere, which it can be because it can randomize, right? So long as that is the maximum distance or something like that is yeah, there's a few parameters. There's like, as long as the radius of the maximally accepted sphere minus the sort of snugness parameter. Yeah, you gotta slap a ness on the end, because you might want to not accept ones which is sort of just dangling on the edge, but so you might want to have a little bit of snugness, as you might call it. So there'll be a little bit of, I think that'll be a 0 to 1 value. So if you have a snugness of 1, it means it has to be like basically touching. I don't think that's really possible to get, especially with randomness. Oh, but you could. No, you can adjust it. How could you? You could have like homing spheres, maybe, that will basically, if they touch, you can make them attach, but then how do you know which way do they go without getting the normal, right? Without sampling a few times and knowing sort of where it is. You know, you don't get the gradient. You don't have the gradient with an SDF unless you sample a few times. So making homing homing spheres is probably not going to be an option, but it's interesting. But yeah, I think this solves the problem. I'll be happy with that. So we want to probably write some of this down. So you want, yeah, maybe we can think about that homing sphere thing and make it work. But so you want to have a parameter somehow. These are the parameters that we're trying to figure out. So you want to have a max. You also want to have like a snugness. Do you do 2Gs? I don't know. So how sort of tight so well, you can call it like, so this is how it's accepted basically, the minimum amount of snugness that's required. You could probably call it overlap, maybe. Min overlap. It's probably a better way of saying it. Overlapness. overlappiness. But yeah, min overlap. So yeah, again, 0.5 probably your basic value. Yeah, just a 0 to 1 value for everything we can. That's the idea. So when you have this sort of geometry material, when you're painting down these detail materials, what can happen is the max radius can automatically, I think, be yeah, so the geometry material should have a way to pass. Yeah, that's it. From like what is the so you see this box here that we've got this sorry. You see this brick that we've got back here in the background. We don't know where the cube is. The cube could be super snug up against the surface, or the cube could actually be a little bit further out. And what you've allowed for then is room for very large detail materials to be plopped down, right? So that room, that extra room, we want to have that passed in, and that helps define the max radius that we're allowed, right? So max radius of 1 is kind of dependent on that value. So we want to find that. So we call it, yeah, this is really cool. This is awesome. So right, Raymarch brick. So the brick, it passes out some stuff, doesn't it? So material, so geometry material hit attributes, they're just random stuff. So we kind of want to have this sort of geometry material you want to call it the so you want to call it the inset, the minimum inset distance. So the min inset distance has to be set. So I'm not sure what that would be, to be honest. We've got so there's probably some parameter which allows it to sort of control so I think with these geometry ones they've kind of got to be in this sort of cuboid kind of shape, or at least cuboid in the way in mesh in material space. The UVs can obviously be remapped, but yeah, they've got to be cuboid like. So that means you probably yeah, this could probably just be applied. Yes, this makes the bricks fit nice and like snug up against the volume, right? So I think you can just have a general parameter. So there's general parameters on the detail material as well, which should happen across all of the detail materials. So the geometry materials probably needs the same thing actually. So I reckon yeah, so Yeah, these are the shared parameters that I want to try and make basically. It's like denseness, the min-max radius, right? And this overlap thing. So they're shared properties. No matter which material it is, maybe they can call them base properties, but I don't usually like that sort of thing. But maybe it's the way, maybe it's the solution. We'll see. See what's best. So somehow with a ray marching of a brick, not just the ray march, is that right? Yeah, ray march, oh, then a shade here. So essentially we need a way so it's not going to change the UV. What is it going to change? It's going to change the, oh no, it's going to change the UV. We might step out further. Maybe. So it makes it appear shrunk. I think that's what we want. Yeah, step out the UV, make it appear shrunk. And that will, yeah, so to do, expose these general geometry material properties somehow. Yeah, so this one will be, we'll call it we had it, the minimum inset distance. So we'll, is it going to be on the material? I don't know, anyway. So the inset distance might be like a 0.1 in material space. And so all that is going to do is say, hey, ray origin ms minus equal array direction ms times this sort of thing here. Now I don't know if we need to do that again some other way. Shading UV. Yeah, I think we might need to do that. So after, on the shade. So do geometry. No. So the shading UV gets modified. Where's that? Oh. Right, so we should be using here shading UV. That's the geometry UV. Cool. So that brick, ray march brick, that shouldn't need to do this anymore. Oh, whoops. set that parameter anymore. Awesome. Right, this is really cool. So now we've got this inset thing. Yeah, so I believe what we can do right, so with regard to these parameters, your max radius is actually a lerp between so you probably want the minimum. Yeah, we basically want to have like a very little amount of parameters to control. I think I want just denseness. So denseness will probably describe, will basically, your denseness of 1, your grid is going to be very small. If your denseness of 0 is just going to be big. And that means the spheres as well probably so yeah, the max inset distance. So that'll be the maximum size of a sphere. And the minimum size of a sphere is probably going to be yeah, so I think you compute Alright, so your denseness. So I think you always want the sphere to be the maximum size of a sphere to be inside a grid cell. You always want it to be not exactly fully there, so maybe 0.9. There'll be a magic number for that. And then that way allows it to sort of offset and move around a little bit still, such that they will look a bit different and hopefully not on a grid. So maybe 0.75. Then your minimum is probably just a quarter of that, I think. And then your grid size would be so basically the more dense they are, the smaller the spheres will get. Yeah, maybe that's the maths we should do. The other way we was trying to do it is like you define the max size first and then you just oh yeah, maybe the way we're doing it is best because this way is like you define the max size first and then you decide how dense it is, and the denseness stops when it's reached making that max radius nice. Making a grid around that max radius. And that's as dense as you're going to get it. It's all defined based on your max radius. So the lower you bring the max radius, the more dense they're going to look. Yeah. Or the more small they are and close together, right? So denseness is like how close they are, basically. So maybe it shouldn't be called denseness. It should be called... What cost... What cost of the most resources? Changing the denseness must be the most costly thing. Yeah. Um, yeah, that's it. So the more grid there is, the more it's going to be, because we've got to ray trace through a grid. But that shouldn't be too bad for a GPU because we're ray tracing this, and ray tracing through this space rather than ray marching should provide it should be better because the steps on average would be larger steps. But yeah, if the dense is like stupidly small and you've got tons of stuff to go through, then obviously it's yeah, it's going to be like stupidly slow. But it should be quite, yeah. So we've got to try and find that sort of, what are we looking for performance basically? How low can we go? You know, you actually might want to have some of these which overlap in a way. Is that true? You may or may. Yeah, you may want it to overlap because say if you want to just like imagine if you've put a volume down and you just want to spawn some like grass, and maybe you've done it with this sort of detail material thing. Um Maybe. Then maybe having the spheres at least be able to go over the edges of the box, but then the whole point of the box is such that if you ray trace through it, yeah, no, we can't do that. So in that case, what we might offer is multiple layers of these things, but then you will get that. Yeah, maybe multiple layers. We'll see. That's a good idea or not. But yeah, the other thing, Kappa, is there is a bit of a performance increase where basically when you hit the surface of the object, it will stop. Like we've already gone and ray trace or ray marched this and received a T to where the surface is. So you only have to go through the grid so much as the until you go past the surface, then no more. Ray tracing has to go through the object, so there is some performance ways to make the performance better, which is cool. Optimizations, that's the word. Super amazing. Right, I'm just going to take a quick break and get another drink, and then we'll sort out these parameters and make them awesome. Let's close this one down. Right, BRB. go. Welcome back. Right, so we're in a really good place. We just got to make these parameters. So these, quick recap, is these parameters are like, so for detail materials where we're spawning these spheres randomly inside of a grid, that if they collide with a surface, then they will be accepted to be ray marchable into, or ray traceable, depends what's inside the surface. What's inside there is up to whatever the detail material shader is. It's incredible. It's awesome. So these sort of shared properties are sort of like between all of the detail materials on about how do you place these spheres down with inside the 3D material volume. So I'm trying to think like, there's two ways of being able to place spheres down, right? So they have to be inside the grid. So there's two ways of sizing it up. We could either make the grid, so basically the denseness controls the size of the grid cells, and you want the denseness, the size of the grid cells, and either as you control the denseness, the max radius will change with it, kind of thing. So the max radius is like inside the grid cell, kind of what is my maximum radius type of value. Or it's the other way around, where the max radius is defined and the denseness basically controls up to that max radius thing, right? And I did it the latter one, right? Where I've done it where you define a max radius, and then that is the one which, and the denseness will go up to that thing. Hence why I've got this sort of code here where it's lerping towards that max radius. And then, so artistically, right? So we always got to think about it from like the user's perspective. What do you want? Well, the object of the thing is placing things down at a certain. They want certain a certain bigness, if you will, certain size, right? So ideally, it would be nice if you can define the size, and then like how much of the stuff at that size do you want? So the size is going to be based on that sort of like geometry material min inset distance. So potentially that is your max radius already, right? That sort of distance you're pushing in that geometry material at such that it becomes smaller is the max radius. Because there's no point. Yeah, so maybe this is the max radius. So this is not really a configurable parameter anymore. And then there's like a min overlap as well. So this one is saying like you might not want a sphere which is like just hanging on the end just to be like, oh yeah, we'll accept that one. No, you want it to be a little bit more snug before you like that, right? So that would be a sort of a min overlap, if you will, sort of parameter. Now, okay, so I think let's think about that sort of grid thing first, and then we'll think if we can have sort of homing spheres that sort of home on to the surface, because that could be quite cool as well, because then it really allows us to reject less spheres and make that denseness parameter seem more amazing. We'll see. So yeah, I like the way we got it. So when it comes to this sort of like this sort of distance thing is kind of like is kind of the max radius. So you probably no, okay, you probably need max radius parameters because maybe if you have multiple layers of different yes, you have a on the geometry material you say like what is the inset distance so I can place some detail on top. And then maybe you can have multiple layers of detail and then you can control that sort of min max radius. So max radius 1 will be like, I want to use the full inset distance. Whereas a 0 would be, we can make it kind of quite small. Now, what does quite small mean? Sort of confusing. It is. What the surface draw down in the red. Oh, okay, this is the confused bit. What the surface draw in the red about if it doesn't overlap and don't care about it. So this is the thing with is the mesh. So essentially you want the mesh and you're ray tracing through it. So an example is so if you did this, right, you have a sphere and maybe inside there's like some moss or whatever, right? Now, if you have a ray which starts from here, so your camera eye is here, and you ray trace against, you've rendered this mesh, so you start your ray here. You're not going to be able to render this stuff, right? Because it's outside the volume. It has to be encapsulated. The stuff we need to render needs to be ensured to be inside the volume. Does that make sense? Because otherwise, based on different camera angles, you would see different things. So if you had a volume like that and then had the moss in here or whatever, there's that special thing that it does. Okay, maybe not. Maybe next time. Anyways, if you had a different one where you had a camera eye from here and ray traced here, what you would get is you would get a you would actually see this object now, right? Because you've come from this way, right? That's basically it. Cool, amazing. Yeah, so this is that whole problem we've been trying to solve out, and this solves it, thankfully enough. So, yeah, I like the idea of max radius and that. So, the problem is, what is that sort of min radius? What does that mean? Like, if we have a massive inset value for the geometry material where it pushes in the geometry, like, right out loud, where it pushes it in more, does that mean my minimum is going to be like less now? Or I maybe want to have. So, so you could make it based off this value, but then it has the thing of like, as I make this thing bigger, then well, min radius could just be this multiplied by min radius, right? So you're saying how much of the is that all we really want? Maybe it is that simple. We like simple here when we can get it to be that way. So yeah, a min radius of 0 is not very nice though. So that doesn't mean anything. Maybe this could be based on a pixel size, but then you get different problems. Yeah, no, we can probably reject spheres based on pixel size. That's another optimization we can do. Yeah, so I think that would be good. You'd never want to use a value of 0 though. That's the thing, isn't it? So maybe these get timesed by 9. But then they can always get kind of small anyway, right? So like, yeah, no, I think a 0 is perfectly fine because it just, you can always have something which is too small. You never know when it is. So just let them control a value from from 0 to 1. Okay, that's fine. So this min overlap thing is interesting. So when you have more overlap, what does that mean you can do? Let's have a think. So we have min overlap such that we can reject stuff like this where it's just hanging on the edge of the surface. We don't like that. So what we actually want it to be is like, we want something like that to be accepted, but not the other one. So it's going to have to be up to, since it is a sphere and it's assigned distance. Like if you have a box and you have a sphere over the box and you're getting a distance, oh, for crying out loud. It's always from the center position of the sphere, isn't it? So if you did that, what is that? It's it's still a distance, isn't it, to the edge, right? You don't. So yeah, maybe. Yeah, so if you had an object like that, its distance would be negative something, whereas this one it would be positive something, wouldn't it? Is that right? Yeah, actually, maybe that's fine. So a value of 0.5 is saying you've got to be attached to the surface in the middle, right? Whereas a value below 0.5 would mean inside kind of thing. That's kind of cool. So in terms of like a min overlap, that would then mean, so we can write this down. 0.5 means center position at least means distance less than equal to 0. Something like that. Yeah, we could do a -1 to 1 value. That also works. Um, yeah, what does this do to the max radius? Because I think you're allowed more radius at that point, right? Because the inset is a guaranteed amount, and that's set to the radius. Oh, for crying out loud, this automatic thing is like crazy. It's like AI brush. Oh, know exactly what you want to do. But you don't. That's the problem. Anyway. So this inset thing is quite cool because that's the maximum radius. Is it, or is it half that? It's something like that, isn't it? It's like that's a very good point. So if you inset by that, oh, that could be the diameter, isn't it? Or is that what you call it? The diameter. Yes. So really, it's actually times a half. Now, the min overlap, what that allows it to do is actually make it such that the spheres can guaranteed that they're only accepted when they're touching not just a little bit, or that will still be rejected. So that therefore no longer go out the box, but it goes something like this. So this means then a 0.5 will mean it has to be actually in the middle at least, or whereas a 1 would mean it can is there's no overlap. Wait. The minimum overlap required to be 0. Something like that. Okay, so you want it to be, so as you get more overlap, so closer to 1, you want this to be, so 1 would mean it has to be like nearly negative the whole thing, which is quite rare to get. So nearly negative the radius, if you will. So then the max radius you're technically allowed is a larger one. So do we want to allow you to change that? But then that's going to kind of change this thing we've just been over in a way. So then the center point stays the same, but then the radius just gets bigger such that it can such that it can actually be like, right, that's interesting. So the more overlap there is, the bigger the radius. Can be. So what does that do? So the bigger that number, so 0.5 effectively only accepts the radius accepts maybe bigger radius will, sorry, 0.5 means it has to be snug, sorry, yeah, so it'll basically 0.5, so it's min overlap times 2. The problem is when min overlap is 0, what's that going to do? Bit weird. Obviously, you don't need parentheses there, but there we go. So we're probably going to call this the sort of scale or something. We've got to work that out though. So right, it needs to be 0.5 by default. Anyway. Yeah, 0 min overlap isn't going to be overlap scale. So by default it's 0.5. So 0.5 when it's 0, when this is 0, we want it to be 0.5. But when it's, no, sorry. When min overlap is 0, we want it to be 0.5. When it's 0.5, we want it to be 1. And when it's 1, we probably want it to be 2. I think. Or is it 1? It's 1.5. So it should be, yes, it's increments of 0.5 based on I think that's what we want. Yeah, so min overlap. So I think it's min overlap plus 0.5 basically, isn't that right? Sorry, 2 secs. Okay, so man, my brain is so tired right now. Too many things today, but we can do this. Right, so let's just write the numbers out so my brain can work. So when min overlap is 0, we want it to be scaling this geometry distance by 0.5. When it's 0.5, want it to scale it by 1. And then 1.5 is just simple addition in it or something like that. Let's see. Isn't it just add at that point? Are we just adding? We're just adding 0.5. Marvelous. So we're just doing this. The scale is just that, I think. Let's double check it. So Yeah, so that should be it. So if you have so that min distance that we've pushed in the so here's the mesh. We've like kind of maybe ray marched in and hit this surface, and that min distance is guaranteed to be uh something, right? It's just something, whatever. So it's that inset distance. So that means the maximum radius for a sphere could be half of that by default. Okay. Marvelous. So if though you're allowed to say, well, the minimum this sphere can be attached to a surface has to have a distance of basically kind of 0 or less, then you are allowed to increase it by another radius, right? Yep. And then, yeah. And then if you go all the way to 1, it's but another radius. Excellent. Cool. So that's super great. The next thing then. Right, so let's plot this out quickly. So 0.5 means... So 0.0 means distance less than radius. Probably less than the radius. And then 1.0 means distance has to be less than negative radius, which basically nothing hits, right? So you're kind of projecting a lot. Ah, very close now. So the one final thing we have is this feature called homing spheres. Right, what's the problem? So the thing is we've got this sort of min overlap now, which is pretty cool. But could there be a way where if something is touching, that we go, you know what? We're gonna make you a so it's touching the surface, but it's not meeting the requirements. The requirements clearly say that it must have a min overlap of this. So could we home this sphere to the surface to get what we want? So the issue with that is it requires getting a normal, which requires 4 depth values to be calculated at an offset, which can get quite expensive depending on the surface of the, depending on the how the SDF is calculated, if you will. And doing that for each sphere, it might not be that bad. No, it kind of is, I think. Yeah. So this kind of acts as a bit of rejection as well, which kind of sucks. You know, we could, the other way you could do is make it provide a gradient for every SDF that you do, but that would be kind of nuts at the same time as well. Yeah, so for now, it would just kind of be a rejection thing. But yeah, it's cool. It's cool. So it's going to reject things. Right. I guess you can just do multiple layers of the same material if you want more denseness. And that would be a way around this problem. Yeah, because that would probably be cheaper than doing this, than per grid cell doing like 3 distance functions. Maybe just doing multiple layers of the same material with a different seed might just be the thing to do. Cool, so I really like this actually. This is super great. So this would be, so 1 means basically the maximum inset distance, if you will, means half of the min inset distance to the geometry. Yeah, so that's what this means. So it's great to have 0 to 1 values wherever you can do it, basically. So denseness. So denseness means so it's a little bit off here. I don't think it's working the way we want, because 1 is clearly not going to just get you a 4x4, is it? Yeah, maybe we don't need the 1 take. Anyway, we'll play around with that. So we want it to be 2 times radius. 2 times radius means it will make the cell fit super snug. And we probably want there to be a little bit more room. So maybe 2.25, maybe. So when it comes to generating the offset, we are generating the offset. So random seed, basically max radius. Yeah, so there's at least, oh no. 2 makes it seem like, no. Okay, so you probably want to do it 1 point. Five. But we've got to work out that sort of maximum offset that you can do. So you at least want a little bit of room to do some kind of offset. Now, max offset, so that would be max radius, generally speaking, if the denseness is low. But as the denseness gets higher, it's going to get squished such that the max offset that you're going to be allowed would be something like, so the minimum between max radius and cell half dim or is it a max? Take away radius. I think that's it. So if your cell size is, your cell size is always going to be bigger than max radius. Yeah, it's always going to be bigger than max radius. So you take away, you want to take the min, I think. Yeah, that's it. Cool. That max offset There we go. Lovely. Cool, so let's start playing around with this. So I think let's get rid of this drawing now. I think that's enough drawing. We've got it all written down, I think. Oh, we didn't write down the things that we want to do, so write the to-do. Basically, spheres are only accepted when right, only accept spheres when they meet the min overlap requirements below. That saves run out too much. The other thing was well, we'll figure it out as we go, really. I forget now. Let's just no, because we didn't want to do the draw and we had that sort of inset distance. Oh, you wanted to do that anyway. Yeah, we probably also want to have a way to sort of reject sphere if smaller than a pixel. Right, that's something not to forget because that would be a good performance increase as well. Okay, so nice. What are we doing now? Where's the material box? That's fine. Just change the denseness. So we did a 0.9 denseness. What does that? Or 8. What does that do? Oh. Is it really not? It's just gonna make them even larger. This is not very nice. Yeah, it's not very good. So say if we shrunk these down to like 0.6. It's how dense can those big spheres be, basically. They kind of look kind of grid aligned though. Maybe this thing would help. Well, that's what the denseness is all about though, isn't it? It's about... Yeah, I think that's fine. Cool. Maybe we should have ways of Yeah, maybe we need some slightly better hash functions. I'm not sure because it's producing kind of similar directions at least. Yeah. It's stuff to play about with, but it's getting very close now. This is super good. So yeah, if you just simply reduce the nice. But yeah, if you make the min bigger, then that's a big problem. Yeah, we can't allow that. That'd be a bug. So maybe the min radius is a nah. Make its own thing. Yeah, we'll just have to ensure that from CPU side or something. Yeah, then you can always have multiple layers of these things on top with different grids, maybe something like that. I think that will help. Awesome. Amazing. Why is that going? Why is it hitting this one? Bizarre. Yes, there's a. Right, so I think this code is pretty good now. We've got to test a few things as well, just a few more things. So if you're outside, starting a ray, outside UV space, material UV space, is that a problem? That's definitely a bug to probably solve out. Alright, so we changed that. Yes, the larger that is, the bigger the radius is, yeah. The more of an insert you add, the larger they will become. That's all manageable from an editor side of things to adjust the detail materials. You see, I wonder for the detail material. So a geometry material is probably going to have to stay for the whole mesh. I was thinking for the geometry material, you might, the detail material, this one that we're working on right now, by placing these spheres down. I was thinking you could probably paint it over in ways, but then we've got this grid thing, right? So you can end up with depending on how the triangles will render, over the mesh, maybe. I was thinking you could probably paint it over, right? But then that could be quite error prone if you don't catch every nook and cranny, because it could have a half sort of rendered sphere, if you will, of a material based on how you paint it down. That is a problem. So I think that's something to think about next time as well. Is there yeah, I think we don't want to we probably most definitely want to support this in some way. We've just got to figure out how. It should be possible. So work out how to support changing the detail material over the mesh without changing without getting any visual or any half rendered objects, if you will. That will happen. The other one was multiple layers. Can we do multiple layers of detail materials? Right, and different kinds. Right, so it's more of a cost, but then very powerful, because you could have like a moss layer and a stone layer. Right, it could be quite nice. Could be very powerful. So yeah, these are the questions I can think of off the top of my head right now. Maybe there's more, but yeah, we're solving this more and more, and it's getting better. So at least the ray tracing stepping code is working. Seems like it might be a slight bug here though. I don't know what that is. It's gone outside of the thing, so there's a check ray going outside of the bottom left. Material area. It thinks it hits a cell, it actually doesn't. All right, we'll look at that next time. Cool. Amazing. Right, so next stream will be on Sunday at 7:30 p.m. GMT plus 1. In the meantime, there's the Discord channel where you come and chat, and there's also a way to support the stream. If you guys want to support the stream, you can support via Ko-Fi and get access to this code to run on your own local machine. Yeah, I'll be checking this one in when we got when we've got a detail material working, so like the moss basically. Been trying to figure out how the code is supposed to be, and I think we've found the way to do it, which is cool. Just got to iron out these bugs here. But yeah, I hope you have a good weekend, everyone. Hope to see you all on Sunday. And yeah, God bless you all. Catch you later.